Let's talk about our cosmic backyard. We're about to go on a grand tour of the solar system. We're going to start at the very beginning, fly past some giant planets, check out some rocky worlds, and head all the way out to the mysterious icy edges. Let's get into it. So, if you really want to get a grip on our solar system, you can't just start with the sun or the Earth. No, our story begins much, much earlier, 13.8 billion years ago, to be exact. To really understand our place in the universe, we have to go all the way back to the very beginning. So, first things first, let's talk about the origin story. I mean, how did we get from, well, nothing to this incredible swirling system of planets and moons and our very own star? Well, it all kicks off with the Big Bang Theory. The main idea here is that about 13.8 billion years ago, the entire universe was crammed into a single point, tinier than an atom, and it was just unbelievably hot and dense. And then, boom, it erupted, expanding violently. And you know what? It's been expanding ever since. That cosmic inflation is still happening today, pushing everything further apart. That's the million-dollar question, isn't it? The Big Bang gave us the raw ingredients, sure, but it took billions of years for that hot cosmic soup to cool down and eventually cook up the solar system that we call home. The best idea we have for how this happened is called the nebular hypothesis. Picture this, a gigantic spinning cloud of gas and dust. That's a nebula. Over millions of years, gravity started to do its thing, pulling everything in toward the center. As this cloud collapsed, it started spinning faster and faster, flattening out into a huge disk. Right there in the middle, where it was super hot, our sun started to form, and in the cooler parts of the disk, little bits of material began to stick together, like cosmic dust bunnies, growing bigger and bigger until, bam, they became the planets. Okay, so we've got our spinning disk. Now let's zoom right into the center of it all, to the absolute engine of our solar system, the sun. You see, unlike planets, which just reflect light, the sun is a luminous body. That's just a fancy way of saying it creates its own light and energy. And it does this through something called nuclear fusion. It's constantly taking hydrogen atoms in its core and smashing them together to create helium. It's basically a giant, non-stop nuclear reaction lighting up our sky. And when I say giant, it's kind of hard to even wrap your head around the scale. The sun is so incredibly massive that it makes up 99.8% of all the stuff in our entire solar system. Everything else, I mean all the planets, moons, asteroids, everything combined is just the leftover cosmic dust, basically a rounding error. And the temperature? At its core, we're talking about a mind-bending 15 million degrees Celsius. To put that in perspective, its surface is a cool 5,500 degrees. It's that insane heat and pressure deep inside that makes the whole nuclear fusion thing possible. And even though it's 150 million kilometers away from us, light from the sun travels so fast it gets to Earth in just about 8.5 minutes. So think about this for a second. The sunlight you might be seeing right now actually left the sun before you even started listening to this. Wild, right? So, we've met the star of the show. Now it's time to meet the rest of the cast. Let's take a tour of the incredible worlds orbiting it. It's time to meet the planets. You can basically split the planets into two main groups, two different neighborhoods. First up, you've got the inner planets, Mercury, Venus, Earth, and Mars. These are the small, rocky, terrestrial worlds. They have very few moons, if any at all. Then you head past the asteroid belt and you hit the outer planets, Jupiter, Saturn, Uranus, and Neptune. These are the massive gas and ice giants, way bigger and orbited by tons of moons. All right, let's start with the inner worlds. First, there's Mercury, the solar system's little speedster. It zips around the sun in just 88 days. Then, of course, there's us, Earth, the blue planet, because about 70% of our surface is covered in water. Pretty important for life, as you know. And our next-door neighbor is Mars, the red planet. It gets that rusty color from all the iron oxide in its soil, and it's also home to the biggest volcano in the solar system, Olympus Mons, which is 3 times taller than Mount Everest. Now, let's head out to the giants. Jupiter is the undisputed king. It's so big you could fit all the other planets inside it. It also spins faster than any other planet, which whips up these incredible storms like the famous Great Red Spot. Then you have Saturn, the absolute jewel of the solar system. Those amazing rings are made of bits of ice and rock, and they're incredibly wide, but in some spots, they're only a few meters thick. And way out there is Neptune, a deep blue ice giant. It holds the title for the windiest planet, with speeds hitting 2,000 kilometers an hour. But hold on, our solar system isn't just a neat little family of a star and 8 planets. Oh no, it is filled with countless other amazing and sometimes weird objects. Let's go explore the wilder side of things. Okay, this is a great one for clearing up some stuff people always mix up. So, an asteroid, that's a big chunk of rock orbiting the sun. A meteoroid is just a smaller piece that's broken off of one. Now, when that little piece enters Earth's atmosphere and burns up, we call it a meteor. That's what you probably know as a shooting star. And if a piece actually survives that fiery trip and hits the ground, then it's called a meteorite. Comets, on the other hand, they're different. They're like giant icy snowballs that grow these spectacular tails of gas and dust when they get close to the sun.
I know what you're thinking. We've gone through 8 planets, but didn't there used to be 9? Yeah. What happened to Pluto?
Well, back in 2006, astronomers officially laid down the law on what it takes to be a planet. There are 3 rules. The first 2 are pretty simple. It has to orbit the sun, and it has to be big enough that its own gravity squishes it into a round shape. But that third rule, that's the real kicker. A planet has to be the gravitational boss of its own orbit, meaning it's cleared its path of any other big objects. And this is where Pluto gets into a bit of trouble. Let's see how it stacks up. Does it orbit the sun? Yup, check. Is it round? You bet, check. But then we hit that third rule. Has it cleared its orbital neighborhood? And that's a big nope. Pluto lives in a super crowded area called the Kuiper Belt, which is just packed with thousands of other icy, rocky objects. Since it hasn't cleared its orbit, it got officially reclassified. But listen, don't feel bad for Pluto. This wasn't really a demotion. In a way, it was kind of a promotion. It became the first member of a brand new, super interesting club, the Dwarf Planets. And among all the dwarf planets, Pluto is still the king. It's the biggest and the brightest one we know of. And that brings our little tour to a close. We've gone from the very dawn of time all the way to the icy edges of our own neighborhood. But it's always good to remember, our entire solar system is just one star system among billions in our Milky Way galaxy. And our galaxy is just one of billions out there in the universe. It really puts things in perspective, doesn't it? And it makes you wonder, what else is out there just waiting for us to find it?